In Java, you can make an array of every well-defined type. Since an array is also a well-defined type, we should be able to make arrays of arrays. Such an array is called a multidimensional array and can be initialized like this. Basically, we have a multidimensional array, and in this case, it's two-dimensional because we have two sets of brackets. And over here on the right, we can just think of this as an array with 5 rows and 4 columns, like that. That would be what this array looks like. Of course, with every element initialized to 0 because this is an int array. Now here's an example. Fill AR2D with ones. So for this one, we can do for int I equals 0, I is less than AR2D.length, I plus plus. And now, AR2D.length is the number of rows because if we think about it, this is an array of arrays where each element is an array. So we have 1, 2, 3, 4, and 5 arrays inside this multidimensional array. So therefore, if we print AR2D.length, we get 5. And then similarly, since AR2D is an array of arrays, we get that we can access stuff like AR2D of 1, let's just say, and that would be this array. So for example, if we tried system.out.println AR2D1.length, then it would be the length of this array, which would be 4. So therefore we can do, in general, for int j equals 0, j is less than AR2D of I dot length, j plus plus, and these are the indices, and now all we have to do is fill the array with 1, so AR2D I j equals 1. And basically here, AR2D of I is a specific row, and then AR2D of ij would be a specific element. Now, how would we print a two-dimensional array? It's very similar to how we would fill the array with ones. Basically, we still need to access every element of the array, so we still need the same code except for this line, which would be replaced with a print statement. Like this, system.out.println AR2D ij, like so. And now if we get rid of these two print statements and then run, it would just be now a bunch of ones as shown below. However, this is not very neat. If we really wanted to put it in like this format, or at least something close, we can do the following. Instead of println, I can do print and put spaces. And now just doing this alone is not enough. It would just put 21s like that. However, after each row, I can put system.out.println. And now all of a sudden, my array is printed out neatly. Here's another example. What would AR2 look like after these changes? Well, for this one, let's keep check the array at the beginning. It would be 0, 0, 0, 0, except with 3 of those. And then what happens when we do ARR 0, 1 equals 5? We're doing row 0 right here, and then column 1 right here, and we're setting that to 5. And what does this do? We're doing row 1, column 2, and then we're incrementing it by 1. Then we're doing row 0, column 3, and we're subtracting 1. And then we're doing row 0, column 3, and adding 5. And we get something like that. And remember that array indices start from 0. So if we print the array, we should get exactly what we got by hand. As shown below. You can also create arrays by listing out elements, just like the following. Just like the one-dimensional array, we can just list out the elements like this. And this would be basically an array with 3 rows and 2 columns, where each element is specifically determined by us. So for example, ARR3 1 1 would be JKL, and then ARR3 3 0 would be an error because this thing only has 3 rows. So when I try to access the row at index 3, that doesn't exist because indices start from 0 and go up to 2 in this array for the rows. Similarly, if I try to do something like system.out.println AR3 0 2, that would also create an error because, well, row 0 doesn't have an index 2 because it only has 2 elements, which are indices 0 and 1. So that would be an error as well. The interesting thing about explicitly defining the elements like this is that you can have arrays like this. Where each row can have a different length. So for example, 4, 5, 7 in this row, 3, 4, 9, 8 in this row, 4, 6 in this row, 5 in this row, just an empty row, and 0, 9, 8, 7. Like so. And some more examples. Here, AR4 4 0, that would be an error because row 4 doesn't have an element. If instead I did ARR4 of 4 dot length, that would be 0. If I did ARR4 of 1 dot length, that would be 4. And if I did AR4 5 2, that would be 8, as shown below. Here's another one. By the way, just like when we're doing one-dimensional arrays, if we're declaring and initializing an array in the same statement, then we don't have to specify the type like that. We can just directly go like this. So for example, now what would this array look like when it's printed? So when I run this code on it, well, let's see. First, it would print 4, 5, 6, and then on a new line 2, 4, 3, and then it would print 0, 0, 0, 0, 0, and then it would print 6, 9, 5, 7. Because remember that multidimensional array is not just a multidimensional array, it's an array of arrays. So therefore, we don't have to put it in this format always. We could, because all we're doing in this type of initialization is basically listing out the rows. And in these rows, I basically just happen to list out the elements, except for this one. And another way to access the elements of the array is just like a one-dimensional array, using a for each loop for every element in the array. And now, this thing works exactly the same way as it would a normal array, so we cannot do something like int I in ARR5 because this is an array of arrays. Java treats this as an array of int arrays rather than a multidimensional array of ints, mostly. So therefore, we must loop through the elements, not the elements of the elements. So therefore, we get for every row in ARR5. Now, as an exercise, what would the following print if we just do system.out.println i.length? Well, that would just print. Well, first, remember this loops through every row, so every time I is a row. So initially I is this, so it would print 3, then 3, then 5, then 4, as shown below. You can also use this type of loop to print the array. So like for every row in ARR5, and now that we have the row, all that remains is to print the row. So for every int in the row, so for every element of the row, because we're allowed to do this now that I is a one-dimensional array. It's an array of int. But we were not allowed to just directly go to int for ARR5 because ARR5 is an array of arrays. So over here for int j and I, and remember, just like I is a row, not an index, j is an element, not an index. So therefore, we can just do system.out.println j. Or if we really wanted more style, we could do system.out.print j in space, and then system.out.println. So if we bring these two pieces of code close together, we notice that these two pieces of code both print the array, the two-dimensional array, and they're equivalent. Except one of them loops through for each row and for every element in the row, and this one does it through the indices. You could also mix it up, so for example, for every row, and then for int j equals 0, j is less than I.length, j plus plus. You could also do something like that. Although remember, if you're doing that, you must system.out.print I of j, because I is a row and j is an index. Whereas here, j is an element, because we're using this type of loop. But over here, we're using a regular for loop, so therefore we must do I of j rather than just j. And this would give the exact same result. Similarly, if we do for every index, so for I equals 0 all the way up to arr5.length, I plus plus, and then we can switch to the for each loop inside as well. So for every int j in, so this time I is an index, so we can't just do for every int j in I. We have to do for every int j in the row. And what is the row? Well, given the index, the row would be arr5 of I. And then here, remember that j is an element, so then therefore we can just directly print it. So print j like that. And the result is the same as shown below. Now let's go back to filling in the array. What happens if we try to do the enhanced for loops, the for each loops, except trying to fill in the array? So for every row in AR6, for every element in the row, just j equals 1. So basically we're trying to fill the array with ones. How would that play out? Well, if we just print the array, we would find out that actually what results is actually a bunch of zeros. Basically, we didn't modify the array actually. Why is this? Well, to explain this, let's go back to the one-dimensional example. And let's try doing that same thing. If we tried for every int I in AR7, for every element in this one-dimensional array, I try I equals 1, and then I print the array, so for every element in AR7, system.out.println I, then what would happen? Well, we would actually get, again, a bunch of zeros. Now, why is that? This is because when we're doing for int I in ARR7, what I really is basically it stores the value of an element of ARR7. By itself, it's not an element of ARR7. So therefore, when we redirect it, all we do is change the value of I, not the value of an element of ARR7. Because just as an illustration, just say ARR7 is something like that. And now I initially would be something like pointed to here in the first iteration of the loop. And now what do I do when I equals 1? Actually, that doesn't change this element to 1. No, because here I is not ARR7 of an index. I is something that stores the value of this thing. So when I do I equals 1, what I'm doing is actually changing I to point to 1 like that. So here if I do system.out.println I, that would be perfectly fine. That would be ones. But that's only because I is already detached from the array, and then I modify I. So therefore the array itself doesn't get modified, just I does. Now let's go back to the two-dimensional example up here. So, as you may notice now, when we do j equals 1 right here, because j is, well, an int that stores the value of an element of the array, all we're doing is redirecting j, just like here, where we're redirecting I. Similarly, over here, we're redirecting j from the array to the value 1. So therefore, this thing doesn't do anything. However, note that the following would work. So this doesn't work, but the following would work. If I do for every row in ARR6, then for int j equals 0, j is less than I dot length j plus plus, and then say I of j equals 1. Now when I print it, it's going to be, well, up here filled with 1s. Now why is that? Well, let's illustrate using the diagram again. If I do the thing over here, basically what's happening here is, just to make this easier to read, because there's only so much I can do on a screen, I'll just call these rows R1, R2, actually R0, R1, R2, R3, and R4, okay? And then we just have that R0 is, say, a bunch of zeros. There's 4 columns, so it's length 4. Similarly, R1 is a bunch of zeros. R2, R3, and R4 are also the same bunch of zeros. Like that. And now, when we're doing for every row in ARR6, okay, this thing is maybe ARR6. So for every row in ARR6, so that's I, we have, so first of all, when it's a row, initially the first iteration, I is pointing to that thing. So therefore, when we're doing I of j equals 1, where j is an index, let's just say j is 0, I'm modifying R0 internally, so now that thing is 1. When j is 1, that thing is 1, and so on. If, however, I was directly doing something like I equals, so like if instead of that, I was doing something like I equals 1, 1, 1, 1, then instead it wouldn't work. It would actually stay as zeros. And the reason is because if I do that, then what I'm doing is redirecting it to a bunch of 1s. Because I'm directly setting I equals in this case. However, over here, I'm setting I of j equals. So I itself is modified. Like, so the element of I is modified. Basically, we're modifying I internally. And in general, when you modify something internally, it changes it. And if you modify something externally, like directly a variable equals something else, normally that doesn't change anything.